Dear students, in this video on current electricity, we will study about EMF of a cell, its internal resistance and combinations of cells, and also numerical problems based on them. So let us begin with the definition itself. EMF or electromotive force of a cell. Now it is EMF of a cell is maximum potential difference between the electrodes of a cell when no current is drawn from it. So आपके पास cells के electrodes के बीच में जो maximum potential difference है वो EMF है. The condition is no current is drawn from it, or we say that the cell is in open circuit. Another point to note is that EMF is not a force, it is potential difference. So its SI unit is volt. Its SI unit is volt because it is potential difference. And see, your cell consists of electrolyte and current has to pass through electrolyte. Now this electrolyte offers resistance to the flow of current through it, and that resistance is called its internal resistance, right? So factors affecting internal resistance. Now starting with the first factor itself, it is with increase in separation between electrodes, internal resistance increases. Now that you have already done cells, you know that a cell consists of electrolyte. It can be say sulfuric acid, ammonium chloride or any other, and you dip two electrodes inside it. Say one is positive, other one is say negative, right? So current flows from one electrode to another within the electrolyte also. So if the separation is more, current has to travel longer distance, charges have to travel longer distances. A longer distance means resistance will increase, right? So this point is very easy to understand, that with increase in separation between electrodes, internal resistance increases. Now the next one. Internal resistance is inversely proportional to area of electrode plates. Now this is also very clear. If electrode plates are wider, then the flow of charges between them will be easier. So अगर electrode plates का area बढ़ाएंगे तो internal resistance कम हो जाएगा. Now the third is internal resistance depends on the nature of electrolyte. Now you understand, different electrolytes have different capability of ionization. So electrolyte की ionization capability और temperature बहुत सारी चीज़ों पर भी internal resistance depend करेगा. Now relation for internal resistance of a cell. It's a very important derivation. So let us try to understand it first. You have a cell with EMF E and internal resistance R. The symbol for internal resistance is small r, right? And current I is drawn from it, which passes through external resistance R. Now you see, the potential difference across external resistance is I into R, Ohm's law that you know. And this V is also equal to potential difference between electrodes of the cell when this current is drawn from it, right? So if you look inside it, the maximum possible potential difference is E by definition. और जब करंट निकालते हैं तो करंट इस इंटरनल रेजिस्टेंस से भी पास हो रही है, तो यहाँ पर पोटेंशियल ड्रॉप हो जाएगा I इंटू आर, यानी कि बाहर निकलने वाला EMF जो पोटेंशियल डिफरेंस जो मिलेगा वो इन दोनों का डिफरेंस होगा, E माइनस आई आर, और दिस इज इक्वल टू दिस potential difference V also. So we are going to do the same thing now. You see, this V is equal to IR, this potential difference V is equal to IR is equal to E minus IR, right? and now current in the circuit will be EMF E upon total resistance in the circuit. Now see, the external resistance R and internal resistance small r, they are in series. जो करंट इससे पास होती है वही करंट स्मॉल r से पास होती है. So total resistance becomes small r plus capital R, right? So now this V becomes equal to I. In place of current I have placed E upon R plus R into R, right? And to simplify it, this small r plus r is taken to the left hand side, नीचे से ऊपर आ जाएगा. इस कैपिटल R को लेफ्ट में लेके आ गए, नीचे आ जाएगा. इस V को हम राइट साइड में ले जाएंगे तो ये नीचे आ जाएगा. ठीक है. It's a very simple techniques of changing the sides that you all are familiar with. And since I have to find out internal resistance R, small r, I'll keep this term on the left and take all other things to the right. So minus 1 when goes to right becomes, sorry, this was plus 1. Plus 1 when goes to right becomes minus 1. Let's look at it once again. I kept this small r plus r upon r on left, and plus 1 is taken to right, so it becomes minus 1. And then take this r also to the right hand side. You get this internal resistance R is equal to E upon V minus 1 into R. Very, very important relation. You must remember it. You will get this derivation in examination straight away, and numerical problems also based on it. Now let us discuss the potential difference across a cell while charging and discharging, right? So look at it. While discharging a cell, as we have just discussed, current is taken out from a cell, and while charging a cell, current enters in a cell. So this we have just done. The potential difference across this cell comes out to be V is equal to E minus IR. But what happens when your cell is discharged, like आपकी बैटरी या जो है मोटरसाइकिल या कार की बैटरी डिस्चार्ज होती है तो उसको दोबारा चार्ज करते हैं, उसको एक बड़ी बैटरी के साथ अपोजिट डायरेक्शन में जोड़ के, like positive of the larger battery is connected to positive of your smaller battery, right? So now the current starts from the battery and enters inside the smaller battery जिसको हम चार्ज कर रहे हैं. ठीक है. So in this battery, current is moving from positive terminal to negative terminal, और स्मॉल r ये जो इंटरनल रेसिस्टेंस है इसमें भी करंट हायर पोटेंशियल से लोअर पोटेंशियल की तरफ मूव हो रहा है. सी करंट ऑलवेज फ्लोज फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल. तो ये वाला पोटेंशियल डिफरेंस हायर से लोअर है, ये वाला पोटेंशियल डिफरेंस भी हायर से लोअर है, दोनों की डायरेक्शन सेम है, सो दे गेट एडेड अप. सो नाउ द टोटल पोटेंशियल डिफरेंस बिकम्स V is equal to potential difference between the electrodes of a cell when it is not giving any current plus its potential difference across this internal resistance. So ये E और ये IR दोनों के दोनों add हो जाएंगे. So when a cell or battery is being charged, the potential difference across its ends is E plus IR, whereas when a battery is being discharged, as in this case, the potential difference is E minus IR. So this is also a very, very important concept and you must remember it. Now, combinations of cells in series. Now, to obtain more current, we need to combine cells together. So here, we have taken two cells, E1 with internal resistance R1 and E2 with internal resistance R2 connected in series. the current from E1 is along this direction and current from E2 is also along the same direction. The positive terminal of E1 is this one and negative is this. The positive terminal of E2 is here and negative is this one. That means negative terminal of E1 is connected to positive terminal of E2. And they both are giving current along the same direction. So they are being added up. So net EMF in the circuit becomes E1 plus E2 and net resistance in the circuit. See, this R1, R2 and external resistance R, they are in series. So equivalent resistance in the circuit becomes R plus R1 plus R2. So the current in the circuit becomes E1 plus E2 upon R plus R1 plus R2. Right. Now what if the cells do not give current along the same direction or they are connected in opposite directions? Like in this case, E1, it's positive terminal, negative terminal, giving current along this direction. E2, positive terminal here, negative terminal here, giving current in opposite direction. So E1 and E2 are in opposite directions. Now if E1 is greater than E2, then net EMF in the circuit will be E1 minus E2. और इंटरनल रेसिस्टेंस जो टोटल रेसिस्टेंस होगा सर्किट का वो सेम ही है because R1, R2 and R, they are connected in series only. So now the current becomes E1 minus E2 upon R plus R1 plus R2. So we can generalize it further by taking n cells in series. So let us take this case. We have taken n cells connected in series. So since they are connected in series and we have taken them along the same direction, so equivalent EMF in the circuit becomes N into E. Equivalent resistance will be external resistance R plus total internal resistance और वो सारे के सारे सीरीज में हैं तो R plus R n times will give you NR. So total equivalent resistance becomes R plus NR. So the current in the circuit becomes NE upon R plus NR. And कब इसको यूज करना है? What is the condition for them to be used? Now if this R is much smaller than capital R, internal resistance is much smaller than external resistance, then the current I will become N times E upon R. We can, in such situation, we can neglect this NR and this I will be nearly equal to or lesser than N into E upon R. अभी E upon R is current drawn from one cell. तो अब हमारे पास ये वाली करंट हो गई N times into current drawn from one cell. तो यानी कि करंट हमारी nearly N times हो जाएगी. We will get more current, right? So this current drawn from obtained will be equal to current drawn from one cell multiplied by N times. Now, what if the cells are connected in parallel? So first situation we take when identical cells are connected in parallel. So this is a simpler option. Here we have connected cells E1, E with internal resistance R containing these n rows and they are connected in parallel. So the potential difference across all the cells is same as that of the external resistance and the net EMF in the circuit will be E only. But net internal resistance, you see, if we consider, then all the R's, small r's are connected in parallel and there are n times n rows. So the net internal resistance will become R upon N. So the net or equivalent resistance in the circuit will be external resistance R plus this internal resistance. Okay. So equivalent resistance in the circuit is this much. So equivalent resistance in the circuit is this much and then current I becomes E upon R plus R upon N and simplifying this denominator you get NR plus R upon n, and this n will go up, taking reciprocal. So you get this relation, right? Now when to use it? Parallel में हम कब use करेंगे? When the external resistance is much smaller than internal resistance. सेल का रेसिस्टेंस इंटरनल रेसिस्टेंस ज़्यादा है और बाहर वाला रेसिस्टेंस कम है, तब हम इसको यूज़ करेंगे. एंड सी व्हाट वी गेट देन. इन दैट केस this I will be nearly equal to n times E upon R. But in that case, I can neglect this term NR, and E upon R is the maximum current drawn from a single cell. So you can see that now we draw a current n times the current given by one cell. तो यहाँ भी करंट जो है हमारी बढ़ गई, और सेल यूज़ करने का पर्पज़ ही है करंट को लेना. सो let us move on to situation when the cells are not identical. A situation like this. Here we have cell E1 with internal resistance R1 connected in parallel with cell E2 with internal resistance R2. Now thing to notice, here the cells are not identical. इनके EMF अलग अलग हैं. So let's see how we treat it. Now if current I is entering in the circuit, supposing we have some external resistance R connected here, right? And current I is in circuit. Now this I1 goes to E1 and यहाँ से ये I1 यहाँ गई. Cell E1 ने current दिया I1. We can look at this way once again. See, cell E1 is giving current I1, cell E2 is giving current I2, and external circuit is getting current I. And if I have a resistance R here like this, then this current I is passing through this external resistance, and at this point again I1 current goes back to E1, I2 current goes back to E2, like this one. Okay, so now we wish to find out the potential difference across this parallel combination. We want to find out this current, and we want to find out the equivalent EMF of this combination, right? So that is the basic aim here. Let's see what we do now. Okay, so now the potential difference across cell EMF will be E1 minus I1 R1. We know this relation. Similarly, for this E2 will be V is equal to E2 minus I2 R2, right? And if you look at it, this current I is equal to I1 plus I2, right? So sum of currents, okay? And from this equation, if you change the sides, you get current I1 is equal to E1 minus V upon R1. You just change the sides and simplify, you get this relation. Similarly, from this equation, this I2 is equal to E2 minus V upon R2, right? And equivalent internal resistance of this circuit. You see, R1 and R2 are in parallel. So their equivalent internal resistance is R1 R2 upon R1 plus R2. ठीक है, आप इसको करेंगे 1 upon R1 plus 1 upon R2, LCM लेंगे, रेसिप्रोकल लेंगे, you will get this much, right? Now, the current in the circuit of the current drawn from this combination is I, and if E is the equivalent EMF, then we will get I is equal to E minus V upon R. This I will be equal to E minus V upon R, right? Now putting all these values in this equation, I is equal to I1 plus I2, we'll try to solve it. Now I've drawn this equivalent circuit, you see. और दोनों कॉम्बिनेशन को हटा के अगर हमारे पास एक ही सेल है E और उनका इंटरनल रेसिस्टेंस है R और they are giving the same current as I, same current I is given by it, then this V is equal to E minus IR, right? And see again here, I is equal to I1 plus I2. I की जगह पर हमने रख दिया E minus V upon R. I1 is E1 minus V upon R1. I2 is E2 minus V upon R2. Now just separate the terms. You get E upon R minus V upon R is equal to, यहाँ भी term separate कीजिए, E1 upon R1 plus E1 upon R1 minus V upon R1. Here you'll get E2 upon R2 minus V upon R2, और हमने E1 और E2 वाली टर्म्स एक साथ कर ली, E1 upon R1 प्लस E2 upon R2, और नेगेटिव टर्म्स एक साथ कर ली, और आप देख सकते हैं कि माइनस V भी कॉमन हो जाएगा, सो माइनस V इंटू 1 upon R1 प्लस 1 upon R2. सो अगर आपको एक स्टेप में करने में प्रॉब्लम है तो आप दो स्टेप में भी कर सकते हैं. नाउ मूविंग ऑन टू द नेक्स्ट स्टेप, I can write this as E upon R minus V upon R is equal to E1 upon R1 plus E2 upon R2 minus V. Now the term inside the bracket is 1 upon R. You know that 1 upon R is equal to 1 upon R1 plus 1 upon R2. Right? Parallel combination is there. Right? So this term becomes V into 1 upon R or V upon R. Now see, V upon R is on the left side, minus V upon R, on the right also minus V upon R. They are cancelled out. We are left with this relation. So the relation is very important relation. Sorry. This is a very important relation. E upon R is equal to E1 upon R1 plus E2 upon R2. Now if you have more number of cells, then you can have E3 upon R3 plus so on. For an cell, En upon Rn. Now one important point to note here. If one of the cells is connected in opposite direction, then in place of this positive sign, supposing E2 is connected in opposite direction, I can write it as minus E2 also. Right? Here in this case, both the cells were sending current along the same directions. So they both were along the same, they both were positive. But if one of the cells is sending current in opposite direction, then in place of E, we will take minus E. Right? So this helps in solving your numerical problems. So I'll give you such examples. Supposing one E is this one, internal resistance. Another one is connected in opposite direction. So this is positive, this is negative, this is negative, this is positive. Right? Then when you take the formula for this E, you will take E as negative, and using the same relation, you will get it. Now, mixed grouping of cells. What if we have both parallel and series combinations together? So here we have chosen identical cells only. So here E with internal resistance R up to N cells in series, and we have similar M rows in parallel and external resistance R. So equivalent EMF will be NE. See, एक लाइन का यहाँ से यहाँ तक का टोटल EMF हो जाता है NE, right? And they all are in parallel. So equivalent EMF is NE. Now equivalent internal resistance. Just try to understand it. एक लाइन का internal resistance है NR. They are in series. And there are M such rows. ऐसे पूरा हमारे पास M लाइनें हैं. तो internal resistance becomes NR upon M, right? So equivalent internal resistance becomes NR upon M, and now the current in the circuit becomes NE upon R plus NR upon M, और इसको आप LCM लेके सिंप्लीफाई करेंगे तो you'll get MR plus NR, or upon MN goes up, you will get MNE upon MR plus NR, right? So this is the current drawn from this. Now again I want to find out condition when this current is maximum. Now for maximum current, this denominator has to be minimum. So let us see what is the possible condition. So condition for obtaining maximum current. So for I maximum, MR plus NR must be minimum, and we can write this as under root MR whole square plus NR whole square. और अगर आपको ये वाला फॉर्मूला याद हो, that a square minus b square is equal to a minus b whole square plus 2ab. I've used this relation. So if you look at it now, under root mr minus under root nr whole square plus 2 under root mr under root nr. ठीक है? Now I want to minimize it. Now see, look at this term, root 2 mr 2 under root mr under root nr. It is positive term, so this can never be 0. I can take this term in the bracket as 0. So if this term becomes 0, you see mr will be equal to nr, or just changing the sides, r becomes equal to nr upon m. And this r is external resistance and nr upon m is total internal resistance. So we arrive at a very important condition. So to obtain maximum current from a mixed grouping, the external resistance must be equal to total internal resistance. If you want to find out the condition for drawing maximum power from a combination of cells, then external resistance must be equal to internal resistance. So this is condition for obtaining maximum power and maximum current. Now let us move on to take some numerical problems. This is a problem from your NCERT book only, and it is asked in examination also. So a storage battery of EMF 8 volt and internal resistance 0.5 ohm is being charged by a 112 volt DC supply using a series resistance of 1.5 ohm. What is the terminal voltage of battery during this charging process, and what is the purpose of having a series resistance? Okay, so I have already discussed this condition with you, and I have discussed this diagram also with you. See, this battery is given to be, charging battery is given to be 120 volt, and the battery to be charged of 8 volt with internal resistance 0.5 ohm and series resistance is 15.5 ohm, right? Now चार्जिंग के लिए इस सप्लाई का पॉजिटिव और हमारी बैटरी का पॉजिटिव एक साथ जुड़े होने चाहिए, एंड करंट एंटर्स इन दिस बैटरी. करंट यहाँ से शुरू होके ऐसे जाएगी. सो द पोटेंशियल डिफरेंस इज E plus IR, right? We have just discussed this in the previous slides. So let's see. The first thing is to find out the current drawn from the battery. So this I is equal to E equivalent upon R equivalent. सर्किट में E equivalent है 120 वोल्ट की बैटरी माइनस 8 वोल्ट की ये छोटी वाली बैटरी. They are connected in opposite direction. Now total resistance is 15.5 ohm plus 0.5 ohm because they are connected in series, as you can see. So you get I is equal to 112 upon 16, that is 7 ampere. So the current in the circuit is 7 ampere. Now V is equal to E plus IR, as we have just discussed. So E is equal to 8 plus I is 7 into 0.5, and simplifying it, you get V is equal to 11.5 volt. So now the potential difference across this storage battery is 11.5 ohm, which is more than its EMF 8 volt. Right. Now the second part is, why should we connect this resistance, series resistance? Now अगर ये series resistance हम यहाँ पर नहीं जोड़ते हैं, you see, this current will become very large, and that can damage the battery. So connection of series resistance is to safeguard the battery and limit the current in the circuit. So now comes the second problem. Similar kind of problem. A car has a fresh storage battery of EMF 12 volt and internal resistance 5 into 10 raised to the power minus 2 ohm. Now if the starter motor draws a current of 90 ampere, what is the terminal voltage of the battery when starter is on? Right? And second part हम बाद में देखते हैं. So let us begin with the first part. See, the terminal voltage of battery will be equal to E minus IR. Right? So 12 minus 90 into 0.05 ohm. Right? While charging, जब हम चार्जिंग कर रहे हैं तो बैटरी से करंट ले रहे हैं एंड बैटरी इज ऑफ 12 वोल्ट. आई की वैल्यू इसको मल्टीप्लाई करेंगे, यू गेट 4.5, दैट इज 7.5 वोल्ट. सो ड्यूरिंग द प्रोसेस ऑफ चार्जिंग, जब हमने कार की बैटरी ऑन की हुई है तो इतना पोटेंशियल डिफरेंस होगा. नाउ द मैक्सिमम करंट ड्रॉन फ्रॉम द बैटरी. सी second case. Now second case is, okay, let us get into the second case. After long use, the internal resistance of storage battery increases to 500 ohm. ठीक है, क्योंकि यूज करने के बाद इंटरनल रेजिस्टेंस बढ़ जाता है. Now what is the maximum current can be drawn from the battery? Assume that EMF of the battery remains unchanged. इसलिए बैटरी का EMF भी कम होगा, पर जस्ट फॉर द सेक ऑफ सिंप्लिसिटी हमने एज्यूम किया है कि उसकी EMF नहीं चेंज हो रही है. So the maximum current drawn from a battery is equal to E upon R. And if E remains 12 volt only and R has become 500, then the current becomes 2.4 into 10 raised to the power minus 2 ampere. And this current is very, very small. It is very weak to start the circuit, you see, start the car. तो आपने देखा कि कार को स्टार्ट करने के लिए 90 एम्पियर की करंट चाहिए, और अगर इसका इंटरनल रेजिस्टेंस इतना ज़्यादा हो जाता है तो करंट हो गई 2.4 into 10 to the power minus 2 ampere. So small. So this current cannot start your car and it needs to be recharged. उसको चार्जिंग की ज़रूरत पड़ेगी. Another numerical problem. It has got 3 parts. So let us look at the diagram only first. See here we have cell 3 volt internal resistance 2 ohm, 5 volt internal resistance 3 ohm and external resistance R. Right? We have to find out this current I when current given from this 3 volt battery is 1 ampere. Right? And these two currents are adding to give this current. You have to find out current I, you have to find out this potential difference, and you have to find out this R. These are 3 parts. So let us look at it. Find the potential difference across R, calculate current in arm EMF, and find the value of R. So these 3 parts we have to do. So let us start with whatever is given to us. So from here you can see E1 is 3 volt, R1 is 2 ohm, I1 is 1 ampere, E2 is 5 volt, R2 is 3 ohm, and I2 has to be found out, which is equal to I. Now potential difference across E1 is V is equal to E minus IR. So V is equal to E is 3 volt minus I is given to be 1, so 1 into 2 you get 1 volt. So from here till here we get 1 volt, and same potential difference इसके across होगा, same potential difference इसके across होगा. So potential difference across E1 is equal to potential difference across E2 is equal to potential difference across R is equal to 1 volt. So we have found out one part. Now comes the next part. Now potential difference across E2 is V is equal to E minus IR, and putting the values you get 5 minus, and this V is equal to 1 volt also, so you get 5 minus I into 3 is equal to 1, or I is equal to 5 Just change the sides, minus 1 upon 3 or 4 upon 3 ampere. So current drawn from the second cell, this one, see, this is 4 upon 3 ampere, right? And see, this current is 1 and this current becomes 4 upon 3 ampere. और यहाँ पर यहाँ से ये वाली करंट आ गई, यहाँ से ये वाली करंट आ गई, दोनों जुड़ गए. सो टोटल करंट इन द सर्किट बिकम्स 1 plus 4 upon 3, right? So the total current in the circuit becomes 1 plus 4 upon 3 or 7 upon 3 ampere. And now comes the last part. Now the R is V upon I. Potential difference across R is 1 volt and current passing through this R is 7 upon 3, and then you get 3 upon 7 ohm. So external resistance is 3 upon 7 ohm. So we have found out all the parts. This R is equal to 3 upon 7 ohm. Potential difference across this V is equal to 1 volt everywhere, and the current in this arm is equal to 4 upon 3 ampere, right? So now comes a very good example from your NCERT only. This is an infinite series of resistances. See, determine the current drawn from a 12 volt supply with internal resistance of 0.5 ohm by infinite network as shown in this diagram, and each resistance is 1 ohm, right? See, so we have this 12 volt supply with 0.5 ohm internal resistance, and it is connected to an infinite series. This is going up to infinity, right? So 1 ohm, 1 ohm, 1 ohm, again 1 ohm, 1 ohm, 1 ohm. So you can see that this unit is being repeated again and again. See, यहाँ पर यही यूनिट है, यहीं पर यही यूनिट है. This unit is being repeated again and again, right? अब ये infinite है, and supposing कि इस पूरे infinite network का resistance है R, तो infinite में कुछ भी आप add कर दो या कुछ भी उसमें से निकाल लो, कोई फर्क नहीं पड़ेगा. तो अगर एक यूनिट ऐड भी कर देंगे तब भी उसका रेसिस्टेंस R का R ही रहेगा, एंड यही कॉन्सेप्ट हम यूज करने वाले हैं, राइट? सो नाउ लेट R बी द इक्विवेलेंट रेसिस्टेंस, एंड सिंस द नेटवर्क इज इनफाइनाइट, adding one more unit will not change the total resistance. So that is the basic idea. So let's see what happens now. This R is my internal R is the equivalent resistance, और इसमें हमने एक यूनिट ये और ऐड कर दी है, राइट? सो 1 ohm, 1 ohm, 1 ohm, और ये मेरी 12 वोल्ट 0.5 ohm का सप्लाई है, ठीक है? सो नाउ वी विल फाइंड आउट इट्स रिजल्टेंट और इक्विवेलेंट. So you can see that this R and this R are in parallel. ये पैरेलल कॉम्बिनेशन है. इस पैरेलल की सीरीज में ये 1 ohm है और ये 1 ohm है. So we can find out the total resistance as this parallel combination 1 into R upon R plus 1 plus 1 plus 1, right? So we'll find out the equivalent circuit, equivalent resistance of this network now. So equivalent resistance will remain R only, as I told you, and this is equal to the parallel combination. I'm just drawing it once again here. R1 and here 1 and इसके यहाँ पे भी 1, right? So this parallel combination gives you R into 1 upon R plus 1. सीरीज में आ गया ये plus 1 और सीरीज में आ गया ये plus 1, right? And simplifying it, take R plus 1 as LCM, you get R plus 2 into R plus 1, right? And cross multiplying it, So on the left hand side, see, r plus 1 multiplies this r, and you'll get r into r plus 1 is equal to, just open it, you get r plus multiply by 2, 2r plus 2, and then you get, open this bracket now, r square plus r is equal to, from here you get 3r plus 2, and simplify the circuit now, simplify the equation now, you get r square minus 2r minus 2 is equal to 0. Now this is a quadratic equation, and you know the solution of quadratic equation, that is minus b plus minus under root b square minus 4ac upon 2a, right? So from here you get r is equal to minus b. Now see, b is equal to minus 2 here. So minus 2 plus minus under root b square minus 2 का square 4 हो गया, minus 4. Now a is equal to 1 here, 1 into c is equal to minus 2, right? So you get r is equal to 2 plus minus under root 12 upon 2, right? And 12 can be written as 2 root 3, और नीचे ऊपर आप 2 कैंसिल कर सकते हैं. So you get r is equal to 1 plus minus under root 3. Now we will consider only plus, because the value of plus root 3 is 1.73. तो नेगेटिव ले लेंगे तो रेसिस्टेंस नेगेटिव हो जाएगा, which is not possible. So we will consider only the positive option. So 1 plus root 3, that is 1 plus 1.73 or 2.73. So the resultant or equivalent resistance of infinite network is 2.73 ohm. Now current drawn from the cell is E upon R plus R. We know this relation. See, internal resistance और external resistance वो series में है, तो हमने, हमारी बैटरी है 12 वोल्ट की, E की जगह पर 12 आ गया, R is 2.73, we just found out, internal resistance is 0.5 ohm, and simplifying it, you get the current drawn from the storage battery as 3.7 ampere. So that's how we deal with the infinite series. And with this we come to the end of this video. Thank you for watching.